Okay, so the first part here, write the complex number 1 minus I in polar form. So the first thing I do here is I'm going to draw a wee sketch just to see where my number is. So the fact that it's 1 minus I means I'm in the fourth quadrant. Okay, so there's my complex number. So because it's in the fourth quadrant, I'm going to find alpha first, and then the actual angle I require is all the way around from here to here. Okay, so that's my theta that I'm looking for. Okay, so and also I need the length of that complex number. So the first thing I'll do is get the length. So r is equal to the square root of 1 squared, so a squared plus b squared. Okay, don't put any i's in here, onto your calculator, and you'll get that that's root 2. Okay, and then alpha, first of all, I'm going to find. So alpha is equal to the inverse tan of imaginary over real. Now I'm taking the absolute values of that. So when you get the absolute value of that, you get pi over 4. So because it's in the fourth quadrant, then this tells us then that theta is actually equal to 2 pi, which is the full way around, minus that alpha. So minus that pi over 4. Okay, and that then will give me an angle of 7 pi over 4. So that means then my number 1 plus I is equal to the square root of 2 times the cos of 7 pi over 4 plus I sine the 7 pi over 4. Okay, now, sorry, 1 minus I was my number. Okay, now the next thing then I have to do is I have to use de Moivre's theorem to evaluate 1 minus I to the power of 9, giving our answer in rectangular form. So we're asked to put that number we just found to the power of 9. Okay, so all this means is I have 1 minus I, and I'm going to put all of that to the power of 9, which means over at this side I have the same thing. I'm going to take my root 2, so I'm just writing down my number again. So I'm going to put a square bracket around all of this, and root 2 to the power of cos of 7 pi to the 4 plus I sine 7 pi to the 4, and then I'm going to put all of that to the power of 9. So the next thing then I'm going to do is I'm going to use my de Moivre's theorem. So de Moivre's theorem tells me that I put the modulus to the power of 9 and I multiply in the power by the angle. So by multiplying in here, I have a 7 already here, so 7 nines is 63. So I'm going to get 63 pi over 4 plus I sine of 63 pi over 4. Okay, now when we look at this thing here, 2 to the power of 9, so if I just bring up my calculator here, we'll see that that's going to give us quite a nasty answer. Okay, so basically if I put in square root of 2 to the power of 9, I get 22.66. So we cheat and we do an even power, which is going to give me 16. So I've taken care of 8 of them now, so I still have a root 2 left. So basically that's 16 root 2, just to keep that root 2 in the answer. So what did I do there? So I just used the fact that root 2 to the power of 9 is the same as root 2 to the power of 8 and by root 2. So basically here, root 2 is the power of a half. So when you multiply a half by an even power, obviously you're going to get an even number, and that's going to give you then an even a whole number there. And we still left with our root 2. So then we go on to our calculator to get these angles, and I get root 2 over 2 for the cos of 63 pi over 4, and I get minus I times root 2 over 2 for my next one. Okay, for my sine. Okay, so the next thing then I need to do with this is I need to multiply those in. Okay, so if I look there, root 2 by root 2 is 2, but I also have a 2 on the bottom, so that's just going to leave me with the 16. And the next thing then is the same thing again. Root 2 by root 2 will give me 2. I have a 2 on the bottom, which will cancel, and I have minus. So 16i minus 16i is the answer to that.